Hello students, welcome to mathematics class. Students, this is part 14 of the chapter Algebraic Expressions and Identities. In this part 14, we will continue solving questions from the exercise 9.5. Coming to the important standard algebraic identities that we have learnt were a plus b whole square, which is equals to a square plus 2ab plus b square, a minus b whole square equals to a square minus 2ab plus b square, a plus b into a minus b, which is equals to a square minus b square, and at last fourth important algebraic identity is x plus a into x plus b is equals to x square plus a plus b times of x plus ab. Here in this we have standard algebraic identities, mainly 3. So apart from these 3, this is one more important algebraic identity, which is the generalization of 1, 2 and this 3. Now we solved in our previous part 13 up to the question number 3. Now we will continue from the question number 4. In question number 4, we have got mainly 7 sub questions. In them you are watching now 4 sub questions. Here simplify. So we are asked to do simplification. Coming to the first one, a square minus b square whole square. If you want to simplify this, you need to use algebraic identity 2, which is a minus b whole square, where in that a minus b whole square, you know a square minus 2ab plus b square. When we are using this algebraic identity 2, watch in this question, do you find in the place of a with the same letter a but a square it is. That means if I want to avoid confusion, same algebraic identity 2 can be written with the different letters also, that is x minus y whole square can be written as x square minus 2 times xy plus y square. Now to avoid that confusion of letter a, I have used now x and y, where in this you could see x as a square and y as b square. Now just substitution in the place of x, I have to substitute a square and whole square minus 2 times of, instead of x, a square comes, instead of y, b square comes, plus y square means b square whole square, which means a square whole square is a power 4 minus 2 times a square b square plus b power 4. This becomes the final answer. So students, you need to have the same algebraic identities 1, 2, 3 with the different letters also, such as x minus y whole square, or you can take some other letters as m minus n whole square. Choice is yours. C minus d whole square, choice is yours. Now we shall solve another question. Now here I am going to solve another question such as second one. Now 2x plus 5 whole square minus 2x minus 5 whole square. See, in this question number 2, method of doing can be any one that I am going to show can be done here. First one, see children, I will expand 2x plus 5 whole square using a plus b whole square, that is 2x whole square plus 2 times of 2x into 5 plus 5 whole square. Now this is minuend. Now I am taking subtrahend, and I will subtrahend also expand it. Before subtrahend I have placed big bracket to avoid confusion. So 2x whole square. Now I am expanding this with the help of a minus b whole square using algebraic identity 2. So minus 2 times of 2x into 5 plus 5 square. So with that if I do, I'll get first minuend 2x whole square is 4x square plus 2 into 2 into 5 becomes 20x plus 5 square is 25. So this is minuend. Now subtrahend, same 2x whole square gives you 4x square minus 2 into 2 into 5 becomes minus 20x plus 5 square gives you 25. Now I will remove this bracket by applying this minus. So 4x square plus 20x plus 25 minus into plus minus 4x square minus into minus plus 20x minus into plus minus 25. Now children, do you find any like terms here? Yes, that is 4x square minus 4x square plus 25 and minus 25. Now I am left with 20x added to 20x, which means 40x. So this is method 1. Now I will discuss another method in the next fresh page. Now students, coming to the method number 2. See children, this is very important, method 2, to solve it in a short way. You know, here I am having a plus b whole square minus a minus b whole square. Children, from this a plus b whole square, which is a square plus 2ab plus b square, and a minus b whole square expansion gives us a square minus 2ab plus b square. We have very important from the identity 1 and identity 2, standard identities 1 and 2 will provide some extra identities. What are those extra identities? Let me take it. First, I am taking fifth one, which is a plus b whole square added to a minus b whole square. This is fifth one. Sixth one, a plus b whole square subtracted or minus a minus b whole square. This is fifth one. And sixth one, opposite, or let me say, just if I interchange now, little making a minus b whole square as positive and a plus b whole square as negative, becomes seventh one. Now watch, if I add this 1 and 2, I will get 2 times a square plus 2 times b square. In short, it is 2 times of a square plus b square. And this sixth one is, when I do subtraction, symbols of subtrahend changes. It gives me a square and minus a square getting cancelled, b square and minus b square getting cancelled, 2ab plus 2ab becoming 4ab. So this is very important one. And now in the seventh one it gives me minus 4ab, just only sign of this 4ab changes, minus 4ab. If you want, you can cross verify. Now see children, is this is like sixth identity type only, this question number 2, obviously. So here what is A? A is 2x and B is 5. Now answer would be 4 times of 2x into 5, which means definitely 40x. We got in earlier question 40x only. You could see here in one step you got the answer, that is 4ab. So extra identities, if you learn from this first and second standard identities, 5th, 6th and 7th, automatically you can do this sort of questions in a easy way. Now coming to the question number 3. Could you observe something like here that is present? Yes. What is that? Here identity 5 is acting here, where A is 7m, B is 8n, which means you will have 2 times of 7m whole square plus 8n whole square, which means, let me change color of the ink. Here 2 times of 7m whole square is 49m square plus 64n square. If you send 2 inside, it becomes 98m square plus 120, sorry, 49 2s are 98 only, na, correct, and 64 2s are is 128 n square. So this is the answer in question number 3. Now I am giving this as homework, question number 4, and question number 4 is bit important one. It won't come under any of this identity 5 or 6 or 7. You could watch it here 4m, but whereas here 5m. So not the same A. Here 5n, here 4n. So not the same B. So be cautious. Fourth, you have to solve it, expand it, compulsory. So fourth one doesn't fall under any of this 5th or 6th or 7th identity at all. So you have to solve it, expanding it. Okay. Fourth is homework for you in this main question 4. Now coming to the 5th, 6th and 7th, I will solve only question number 7. So 5th and 6th homework I am giving for you. So coming to the 7th question, see m square minus n square m whole square. I will expand it first. So m square whole square minus 2 times of m square into n square m plus n square m whole square. I did first that expansion plus this extra part as it is I am writing. Now m square whole square is m to the power 4 minus 2 times m square into m becomes m cube, and the n square comes as it is, plus n square m whole square becomes n to the power 4 m square plus 2 m cube n square. Now you could find these two being like terms, and one is negative, another being positive with the same coefficient, minus 2 and plus 2. So get cancels. Obviously the answer is m power 4 plus n power 4 into m square. So this is the right answer. So note down question number 5 and question number 6 as your homework. Next, coming to the question number 5. In question number 5, you have got totally 5 main questions, sub questions. In the 5 sub questions, you will be given any 3 as a homework. So, coming to the question number 1 and 2, I will solve any one. So, let me take second one, I will do it. When we are asked to show that, so take always LHS. So, in the second question, what is LHS? 9 times P minus 5 times Q whole square plus 180 times of P into Q. I will do first expansion. 9 times P whole square minus 2 into 9 times P into 5 times Q plus 5 times Q whole square plus 180 times of PQ, which implies, now see children, I am keeping 9 times P whole square as it is, only I am expanding this middle part. So, 2 into 9 into 5 becomes 90 times of PQ plus 5 times of Q whole square I am keeping as it is, whereas plus 180 times of PQ. You could see here these two terms being like, so if I simplify, it becomes 9 times P whole square plus 90 PQ, because minus 90 and plus 180. So, obviously plus 90 will be there, plus 5 times Q whole square. Now, here to expand this, I have using standard algebraic identity 2, okay, and now using here standard algebraic identity 1, that is a square plus 2ab plus b square equal to a plus b whole square. So, we can write this as 9 times P plus 5 times Q whole square. Why I have written that way means, here in between I have skipped one step. Let me write it here, because I have written 9 times P whole square plus 90 PQ, I can write it as 2 into 9 P into 5 Q. So, 2 into 9, 18, 18, 5 is 90 only comes, plus 5 Q whole square. So, here in between that step I have skipped, I have written here, and afterwards I could write like this, which implies or which is equals to RHS. So, I started from LHS, arrived at RHS. Therefore, I can say LHS equals to RHS, makes me to say that this statement once again I will write, okay, due to lack of the space I am not writing, you will write once again this given one. So, children, this is how we need to show that. So, show that questions are very important, which will have lot of working steps and reasons. So, working steps and reasons will carry marks. While writing, be cautious, you have to follow all the procedure to gain full marks. Now, students, coming to the question number 3, 4 and 5 of the main question 5, I would like to solve question number 5. This is one of the important question. You know, a minus b into a plus b, by using algebraic identity 3, a plus b into a minus b is a square minus b square. So, this is algebraic identity number 3 I am using. Using it, I can shorten it as a square minus b square, plus this becomes b square minus c square, then plus this becomes c square minus a square. Now, children, I am starting from the LHS from this step. So, I have written this step This is second step. Third step is removing bracket a square minus b square plus b square minus c square plus c square minus a square. Now plus c square minus a square minus a square plus a square minus b square and plus c square get cancels. So 0 you will get. It is equals to RHS. So LHS equals to RHS. Thus a minus b multiplied by a plus b plus b minus c multiplied by b plus c plus c minus a multiplied by c plus a gives you 0. So, we will conclude like this. So, question number 3 and 4 I am giving as homework for you. Do it properly. Okay. Coming to the question number 6. In main question number 6, you have got many sub questions, somewhere around 9 sub questions are there. In them I will solve only few questions. So, coming to the question number 6, sub questions 1 to 4 are shown, where 71 square, 99 square, 102 square, 998 square. Here I will give only hint. Children, 71 square can be written as 70 plus 1 whole square. It is easy to solve. 99 square can be written as 100 minus 1 whole square, and 102 square can be written as 100 plus 2 whole square, and 998 whole square can be written as 1000 minus 2 whole square. So, if you expand them using algebraic identity a plus b whole square or a minus b whole square, you will get the quickly answer. For example, when it comes to the 99 whole square, 100 minus 1 whole square becomes 100 square minus 2 times of 100 into 1 plus 1 square. So, 100 square is 10,000 minus 2 into 100 into 1 is 200 plus 1. So, from 10,000 take away 200 gives 9,800 and plus 1 is, so 9,801. So, this much easy it is. We need not multiply 99 into 99 at all. So, I hope you will find them properly. With this hint, rest of the questions I am giving homework. And now coming to the question number 5. Question number 5. In this question number 5, to find out 5.2 whole square, you write it as 5 plus 0.2 whole square. So, it becomes 5 plus 0.2 whole square is nothing but 5 square plus 2 into 5 into 0.2 plus 0.2 whole square, which is nothing but 25 plus 2 into 5 is 10, 10 into 0.2, it is so easy, it removes the bracket, plus 0.2 whole square is 0.04. Now 25 plus 10 into 0.2 becomes 2 plus 0.04. 25 plus 2 is 27 plus 0.4 is 0.04. This is the answer. So, this much easily you can solve them. Next, coming to the next question number 6, sub question number 6. 6 to 9 are of one type. So, 297 into 303 can be solved by taking 300 minus 3 into 300 plus 3. It is like a plus b into a minus b. So, when you are using a minus b into a plus b, which can be written as a minus b whole square, here we will write 300 whole square minus 3 square, because A is acting as 300, B is acting as 3. So that means 300 is 90,000 minus 27. Now it becomes 89,963. 63 or 73? It is 73. So 89,973 is the right answer. So children, we have rest of the questions that you can answer easily. I think I have gone somewhere wrong. Let me check. 1 minute. Here, see children, I went wrong by taking 3 square as 27. It is actually, let me erase it. It is 3 square is 9. So when 90,000 minus 9 gives 89,991. Okay. So anyways, it is the one more mistake that I have committed and learnt in the sense corrected myself. Okay children, here rest of the questions in the main question 6, you can answer them with the same procedure, writing 78 as 80 minus 2 into 80 plus 2. You will write this one, and 8.9 whole square. How will you find 8.9 whole square? 8.9 whole square can be using algebraic identity. Same, 9 minus 0.1 whole square. We can find out 9 minus 0.1 whole square. We can find out. And here question number 9, you can write it as 1 plus 0.05 multiplied by 1 minus 0.05. So you can do it this way also. So it becomes 1 square minus 0.05 whole square. So you can find this way too. Children, we have got another important main question number 7. In main question number 7, again you are asked to use a plus b into a minus b only, but from a square minus b square you have to split that way. Here 51 square minus 49 square can be written as 51 added to plus 49 into 51 minus 49, where 51 plus 49 is 100 multiplied by 51 minus 49 is 2, it gives 200. So you need not calculate 51 square and 49 square and all. It is that easy. Now coming to the question number, let me solve question number 4. In question number 4, 12.1 whole square minus 7.9 whole square, will split that 12.1 added to 7.9, further 12.1 minus 7.9. You know 12.1 added to 7.9 gives 20 into 4.2. So 12.1 minus 7.9 is 4.2. So 11 minus 9 is 2, and here 11 minus 7 is 4. So 20 into 4.2 is 42, 2 is 84. So 84 is the right answer. So in question number 7 also there are 4 sub questions. In them first and fourth I did. So rest of the second and third I am giving as homework for you. Then coming to the question number 8. In main question number 8, where you are asked to use x plus a into x plus b, which is x square plus a plus b times of x plus ab. There are 4 sub questions. I'll do any 2 questions, rest 2 you will be solving. So here in 1 and 2 I'll solve second one, where 5 plus 0.1 multiplied to 5 plus 0.2 gives 5.1 into 5.2. Here you could see x as 5, a as 0.1, b as 0.2, where in the expansion I'll write it as 5 square plus sum of the 0.1 and 0.2 multiplied by 5 plus 0.1 multiplied by 0.2, where 5 square gives 25. Sum of 0.1 and 0.2 is 0.3 multiplied by 5 plus 0.1 into 0.2 is 2 ones are 2, but after point I have to have 2 decimal places, so 0.02 is the product. Now 5 3s are 15, so 15 becomes, after point I need only 1 decimal place, so 1.5 plus 0.02 plus 25, it becomes 26.52 being the right answer. So children, you can cross check. 5.1 when it is multiplied by 5.2 gives 26.52. So we have used this identity and solved. So this is the question number 8, main question number 8 and sub question number 2. So next we have got main question 8, third and fourth sub questions. In this I will solve for your comfort. Here I will solve question number third. 100 plus 3 multiplied by 100 plus half minus 2, where x is 100, a is 3 and b is minus 2. So that 98 comes 100 plus half minus 2. So 100 minus 2 only it is finally. So on expansion it becomes 100 square, and sum of 3 and minus 2 is multiplied by 100 and plus 3 into minus 2. So 100 square is 10,000, and sum of 3 and minus 2 is 1 time of 100, and product of 3 and minus 2 is minus 6. Now 10,000 added to 100, 100 added to 100 it means, and subtracted 6. So 100 minus 6 is 94. So it becomes 94 added to 10,000 gives you 10,000 and 94 is the right answer. So children, we can solve this way. And if you want to solve fourth one, in 2 ways we can solve. It is written as 9 plus 0.7 into 9 plus 0.8, that is one way. Another is 10 minus, I am writing it as plus half minus 0.3, so it becomes 9.7 multiplied by 10 plus half minus 0.2, that means 10 plus half minus 0.2, 10 minus 0.2, which gives 9.8. This is another way we can solve. So with this, all the exercise questions of 9.5 are over, and this chapter is also over. So I'll give Friday as the deadline to solve this homework questions. I hope we'll be gaining good knowledge out of the homework that you are solving. Okay, I'm using homework app to give you homework. I expect everybody solving those homework questions and sending me back, and surely you'll be gaining good experience while solving homework. It will fetch you in your exams. So with this, I'll wind up this chapter, children, and take care of yourself. Jai Hind. Thank you.